All right, so we done the one variable statistics. Now we're starting with two variable statistics. So let's start with the first lesson. You understand the meaning of scatter plot when we have two variables given. We have one independent and dependent variable. You learn how to make a scatter plot in grade 9 or maybe grade 10 or even grade 8. We know we have to first thing we have to identify what are those variables and which one is the dependent variable and which one's independent variable. And when we make a scatter plot, we always put independent variable along x-axis and the dependent variable is along y-axis. There are some situations where it's hard to define which is independent, which is dependent. So in that case, you can assume one of them is dependent, one of them is independent. There are a few cases when it's hard to define which one's independent variables. So I'm gonna later on talk about one example like this, or maybe in next lesson. So you know how to make scatter plot. We have a lot of points given and we show those points and then we learn how to make a line of best fit. Our next lesson will be how to find the best line of best fit, but now we were just talking about the scatter plots and to find the relationship between those variables. So we talk about two variables, dependent and independent variable. So a little bit reading here. I don't think I need to read it. So define x and y as dependent variable, x as independent variable. So we want to find the relationship. So the statistic we're dealing with now with two variables instead of one variable as compared to what we done in the other chapter. So we make a scatter plot. From scatter plot we try to define the kind of relationship between dependent and independent variable. So we talk about the linear correlation means when we can make a line showing the relationship between dependent and independent variable. So if we have a strong positive, strong negative, weak positive, weak negative, and in cases there's no relationship between the variables. So we have a perfect positive indicating all the points are on a straight line. Y is directly proportional to x. And when we have strong positive, so we talk about perfect positive, we talk about strong positive, we have moderate positive, we have weak positive, we have no correlation. Same thing, it may be negative relationship, a perfect negative, strong negative, moderate negative, weak negative, and no correlation. These terms are already done. That means if we can make a scatter plot, we can understand what type of relationship is there between x and y. But now we want to learn in this lesson how to check this algebraically. And is there any other way? If you don't want to make a scatter plot, can we do another way to find the relationship between x and y? Okay, so this is what for the correlation strength. We talk about the positive. Same thing, we might have a negative. We have perfect negative, strong negative, moderate negative, weak negative, and we have no relationship between x and y. This is what we done by using scatter plot. Now we will be learning algebraically, doing some calculation and to figure out is there any coefficient, is there any constant we can define which will, without making scatter plot, will tell us the relationship between x and y. So that's what the lesson is. We talk about the coefficient. It's called correlation coefficient R. It's found by Pearson. It's called Pearson R, or sometimes written as PPMC. So that's a longer form for this, defined by Pearson. So it's called Pearson R. You can look at the definition what PPMC stands for. I don't have in my head now. So this is called Pearson R. So we have a coefficient, we have a constant which can define the relationship between y and x without making scatter plot. if the R value are between -1 to +1, for +1 indicate a strong positive, means perfect positive correlation between y and x. -1 indicates perfect negative correlation between x and y. And from 0 to 0.33 value is considered weak positive. Same thing, 0 to -0.33, it will be weak negative. Then we have moderate positive and moderate negative. The values of R will be -0.33 to -0.67. Same thing, moderate positive is 0.33 to 0.67. So anything greater than 0.7 to 1, 0.67 to 1 is strong positive. Same thing, -0.67 to -1 is strong negative. If it's exactly 1 and -1, and we call it positive, perfect positive correlation and perfect negative correlation. So the R value, the PPMC coefficient or Pearson R value is always between -1 to +1 for a linear relationship between y and x. Now question is how we find it. If we don't want to make a scatter plot, and what's the way to check the relationship between y and x? So we need to know how to do calculation for R. So this is what we call Pearson's R. So I have this the abbreviation we have PPMC, stands for Pearson's product moment coefficient of correlation. So he found it. It's either called Pearson R or PPMC formula. It looks like a big heavy formula, but if you understand the terms used, and we just have to do calculation and plug in the values. N in this case indicates the number of records, number of rows in the table. XY, sum of XY, this sum of XY indicate the multiply all x and y values, we add them together. So this is sum of XY. So this is sum of x, means simply add all the x values. And this is sum of y, means adding all the y values. And this is sum of x square, means we have to have a square of all the x value, we add them. And this is sum of x then whole square, means we already found sum of x, we square it. And sum of y square, again we add all the y square values. And sum of y whole square means first we add the y values, then we square it. If you understand, if you know this formula, you don't need to know how we derive this formula, we just need to know how to use it. And a lot of calculation needed, so a lot of people will simply do on calculator, find all x, y values, add them, find all the x value, and keep in plugging in the values. I'm going to show you how we can actually, I prefer that we can make a table. We already have the x column, we have y column. We can create a column which is xy, we can create a column which is x square, and we can create a column which is y square. I'm going to show you one by example here. And we just plug in the values. And without making scatter plot, we can find what kind of a relationship is between y and x by using the R value. So I have, I already talked about what's the meaning of x square sum. What's the meaning of sum of x then whole square? Means we add all the x values, then we square it. Here we find square of all the x values, then add it. So remember, so this formula will be given. It's not easy to memorize it, so you will be actually given in questions. Okay, so I have this example. By taking this example, you will understand how to find the R value. So we have data given, we have different type of vehicles given, and their the power of the engine is given, and then the fuel consumption is given for each type of engine. So first thing we need to identify what's a dependent variable, what's independent variable. So I will say X is the horsepower, the size of the engine. Bigger the size and more will be fuel consumption. So that means that the dependent variable has to be the fuel consumption. And the size of the engine, this will be the independent variable. So once we define the dependent independent variable, so it's better you can make a table like this, like I did. So we have the x value, we have y values. I will create, this is what I do. Some people will simply use the calculator and then find the sum of all x, y values, sum of all the x square and y square. You can do it, but there's a chance that you might miss something or miss a term, miss a value. So it's better you create a column xy. You can create a column for x square. You can create a column with y square, and then just do the calculation. xy means multiply first x value, first y value, and same thing, second x value, second y value. And x square column will have all the x square values. For example, 105 square here, and 170 square will be here, 124 square will be here. Same thing, you create a column for y square, because in the formula we need to know what sum of all the x value, what sum of all the y values here, and then what's the sum of all x and y values, the product of x and y, and what sum of x square values, sum of y square values, and also the number of records we have. In this case we have 5 different type of engines, so NH 5, and then we just plug in the values. Be careful what goes where. So this is sum of x and y. We've got this value 7974.3 and multiply by number of records minus sum of all x values times sum of y values. That means 712 times 47.9. So I did substitute here. So this is square root, and denominator is square root, but n is 5, and we have to multiply by sum of x square values, which comes from here. And this is sum of x then whole square. Sum of x is 712, we have to do square. Same thing, 5 times sum of y square values, and then minus sum of y then whole square. So I did calculation. The answer is 0.353. If you look at the r values, remember r comes from 0 to 0.33 and 0.33 to 0.67 and then 0.67 to 1. This is slightly more than the weak positive correlation. So I will consider this as a moderate relationship between the y and x value. So in this case, the size of the engine and the fuel consumption, the relationship is moderate positive correlation. So we can actually define it by using a scatter plot, or we can do calculation using this formula, PPMC method. I'm going to show you how to do this in using technology. So I have same data, the x column, we have the y column here, all those are x values and y values. So we can verify it by using the Excel. There's a built-in function in Excel. So I'm gonna just write here, and it's simply called correlation, CO. We can type CO. You will see there REL, it's already there. And then we just pick the first column, which is x values. So I can pick this one, but I don't need to pick all those values. I can just write the range of values. So I can start from here, and I can pick here, this is first column, and then put comma, it says array 1 and array 2. This is second column, and then close the bracket and enter. It gives me same value, 0.35061,007. This is a more accurate value, but the calculation we found here is this 0.353. So that means we can verify by using technology. So it's a correlation. I use Excel, but there are you can actually use some other programs too. So I'm going to use Excel because next lesson we'll be doing how to find the best line of best fit. So I can use a similar example there to explain it. So anyway, so our goal is to find the R value and then verify the answer. Okay. So that's the example. You can try a few of your own and to understand how you will be doing it. Now, one more thing, actually, we talked about the relationship. If we show on a graph or finding the R value, sometimes there's no correlation between the variables. So we will be talking about different type of relationship like cause and effect. For example, one of them, reverse cause and effect. Sometimes there's a strong positive correlation, but actually there's no correlation. That's accidental relationship between those variables. I have one example here, so I'm going to talk about this a little bit here. One more thing to remember, that if you have a large number of data points, a more accurate your answer will be, rather than just having 2 points, for example. And we can determine what type of relationship is there between just 2 values. We have to have a large number of values. More the data points we have, more accurate the answer will be. And then we talk about the correlation coefficient. Sometimes it doesn't tell exactly there's a relationship. Sometimes there's no relationship, it's accidental. So I take this example here. We talk about cause and effect relationship, reverse cause and effect relationship. Sometimes there's an accidental relationship. Just knowing the R value sometimes is not enough. For example, I have this example here. This seems to be a moderate or strong positive correlation unless we do find the values. So just looking at the graph from scatter plot, it looks like it's a positive correlation. Correlation between number of people visiting Canada's Wonderland and the size of potato harvest. Even if it seems to be a positive correlation, but that doesn't mean there is a relationship. So it had nothing to do with the number of people coming to Wonderland with the size of a potato harvest. It has no relationship. Even if it's scatter plot, or even if you find the R value, will show there's a positive correlation. Anyway, so we have a separate topic for this one, the type of relationship and what type of, like I already mentioned here, cause and effect, reverse cause and effect, accidental relationship between 2 variables. Anyway, so that's not the topic. We will talk about this in one of the other lessons. So main thing is, if we don't want to make a scatter plot and we have to use PPMC formula to find the type of relationship between 2 variables. So follow this example once more. Learn how to use the formula. Just do practice on a few questions and then you will be fine. And our next lesson will be finding the line of best fit algebraically, means using the formula. So this is your homework question. 2, 3, 5, 6 and 7 you can look in the textbook, and I hope you understand. You just need to know how to use the formula. It looks like a heavy formula with a lot of calculation. You don't need to know how the formula was derived. You need to know how to use it to find the relationship. And that's it. Okay, so hopefully you ready for next lesson. I'm gonna be making next lesson on the best line of best fit, basically. All right, so see you guys in next lesson. Bye.